Next properties of relation is nothing but symmetric relation. A relation R on set A is called as symmetric if B comma A is belongs to R whenever A comma B belongs to R for all A comma B belongs to A. So if any pair, order pair of kind A comma B belongs to relation R, then B comma A should be exist. It should be satisfied for all A comma B belongs to A. Then that relation is called as a symmetric relation. Consider the example relation R, which contain the pair 1, 2, 2, 1, 3, 2, 2, 3 on set A, which contain element 1, 2, 3. It is a symmetric because if you see all order pair, if order pair 1, 2 is exist, then 2, 1 is also there. 3, 2 for 3, 2, 2, 3 is also there. So this relation is R is called as a symmetric relation. Then antisymmetric relation. A relation R on set A is called as antisymmetric if A is equal to B whenever A comma B belongs to R and B comma A belongs to R. Means if symmetric order elements are exist, then A equal to B also should be exist, then it is called as antisymmetric relation. Then asymmetric relation, next property. So a relation R on a set A is called asymmetric if A comma B is belongs to R implies that B comma A not belongs to R for all A comma B belongs to A. Means a relation is called as asymmetric if A comma B is belongs to R but B comma A is not belongs to R. It should be present for all pair of kind A comma B. Then it is called as a asymmetric relation. Next property on relation is transitive. A relation R on set A is called as transitive relation if whenever A comma B is belongs to R and B comma C is belongs to R, then A comma C belongs to R for A comma B comma C which is belongs to A. Means relation R is called as a transitive relation if for every pair A comma B which is exist in relation R, B comma C is also exist in relation R, then A comma C should be present in the relation R. Then that relation is called as a transitive if it is exist for all such kind of pairs. Consider the example, the relation R which containing the pair 1, 2, 2, 3 and 1, 3 on set A is equal to 1, 2, 3 is a transitive because if you see there is a pair 1, 2 and means 1 is related with 2, 2 is related with 3, therefore 1, 3 should be there and it is exist. That's why this relation is called as a transitive relation. Now on the basis of these properties whatever we studied, this is the study assignment for you. Consider the set A which containing the elements 1, 2, 3, 4, 5, 6, 7, 8, 9 and you have to form the relation such that first R is not reflexive and not irreflexive. Second relation R is symmetric as well as antisymmetric. Third, R is transitive but not symmetric and not reflexive. And fourth one, R is transitive, reflexive but not symmetric. So you have to form such relation using the Cartesian product of A cross A. Now next type of relation is equivalence relation. A binary relation that satisfies following properties is called as a equivalence relation. Which are the properties? Reflexive, symmetric and transitive. Means a binary relation if satisfy or if it is reflexive, symmetric and transitive, then that relation is called as equivalence relation. Consider the example R is equal to 1, 1. R is a relation which containing the pair 1, 1, 2, 2, 3, 3, 1, 2, 2, 1, 2, 3, 3, 2, 1, 3 and 3, 1. on set A, that is 1, 2, 3. It is an equivalence relation since it is reflexive, symmetric and transitive. So if you see the relation R on set A, here it is called as a reflexive if for all A belongs to A, if A comma A order pair is exist in relation R, then we can call it as a reflexive. In this case, elements of the set A are 1, 2, 3, and so 1, 1, 2, 2 and 3, 3 pair should be there. So these pairs are present in the relation or exist in the relation. So it is reflexive relation. Second property is that symmetric. Symmetric means relation R is symmetric if for all A comma B belongs to R, B comma A also should be belongs to R, where A comma B comma A comma B comma C whatever is should be belongs to the relation should belongs to the set A. In this case, if you see 1, 2 is present in the or it belongs to set R, therefore 2, 1 should be belongs. It is present for 2, 3, 3, 2 is present, for 1, 3, 3, 1 is present. Therefore this relation is symmetric also. Next property which need to satisfy for equivalence relation is transitive property, and as per transitive property, relation R is transitive if A comma B is belongs to relation R, then B comma C is also belongs to relation R, then A comma C should be belongs to relation R. It should be satisfied for all this kind of pair, that is A comma B, B comma C. A comma C should be exist. Then in this case, if you see 1, 2 means 1 is related with 2, 2 is related with 1, therefore 1, 1 should be belongs to R, it is present. 1, 2, 2, 3, if you see these two pair 1, 2, 2, 3, 1 is related with 2, 2 is related with 3, therefore 1, 3 pair should be there, so it is exist. Then if you see 3, 2 and 2, 1, so 3, 1 should be there, so it is exist. So you can check for all such kind of pair A comma B, B comma C, A comma C should be exist, then it is called as a transitive, and here it is satisfying. So if all these three properties are present in the relation R, then that relation R is called as a equivalence relation. Now next theory is that equivalence classes. So it is related with this equivalence relation. Let R be an equivalence relation on a set A. The set of all elements that are related to an element A of A is called the equivalence classes of A. Means A is an element of set A, then equivalence classes with respective element A is called as equivalence classes of A. So you can see the example here. The equivalence class of A with respect to R denoted by AR.